Today we are going to run a model on AMOS, and for that purpose I have a sample data with me, in which we are going to have some independent variables, one mediating variable and one dependent variable. So let's start by uploading the data file. First of all, we have to select the data file in AMOS by using the icon given here. I'm selecting the data file. I have saved it in a folder named AMOS model. So it's better to save all the data including the AMOS output and AMOS model in a separate folder so that you can find it afterwards. So I am selecting this data file, and we have got that there is the data of 250 records in this Excel file. It's the CSV file format. So you can also upload the SPSS file over here. Even an Excel file can also be uploaded. But right now I have a CSV file in which there is a record of 250 responses. Uh, Before running AMOS, you must have to ensure that you have already calculated the reliability, validity analysis, and the normality analysis, because AMOS is based on the covariance based SAM approach that requires the prerequisites of all reliability, multi-collinearity checks. So you have to go through all the tests before running the model on AMOS. So right now I'm selecting the variables, and first of all we need to check that how many variables are there. So by using these icons we can see that how many variables are there in the data set. So we can see that there are uh, one latent variable of JS, then another latent variable of WP, then another then these are the items of that the latent variable that we need to make in AMOS. uh, So let's start. 1, 2, 3, 4, 5, 6, 7. So we have in total 7 variables. So let's draw 7 latent variables, and the maximum of the variables we have are 9, and the minimum of the indicator variables we have 3. So on an average we have to make a 5 variable uh, latent variable, 5 item latent variable. So we are going to draw the latent variables using this icon. As you can see that when I just click over here, it has drawn a big shape. So let me reshape the construct so that all the items can adjust over here. So I am clicking again on the latent variable and it will add the items on it. So first latent variable is having 6 items. Then I'm just selecting these variables and copying the data. One arrow is left, so we select that arrow as well. Now I'm going to duplicate the objects. Second variable. Oh my god, I don't think so. It's getting the complete data set. So let me. Okay, there are some boxes left. Okay, now I'm duplicating the objects. 3, 4, 5, 6 and 7. So in total we have 7 variables, I guess. 1 2 3 4 5 6 7. Okay, so let me start by putting the variables on items. We need to deselect all the variables. So first I'm going to add a JS variable, that is over here, JS. First item of JS, then the second item of JS, and the third item of JS, and fourth item of JS, and after that the fifth item of JS. We'll delete the remaining ones, but let us first put all the items on the constructs. So another one is WP. So let's start. WP1, WP2, WP3, WP4, WP5, and WP6. So 3 items are still remaining. So let me add 3 more items. So I'm also adding the 3 items on this latent variable, and I have put all the indicator variables in these rectangle boxes with the latent variable over here. So another construct is WE. So WE1, WE2, WE3. As I said that the remaining items will be deleted afterward. You can see that the box is actually not not inserted in the existing box, but it was overlapped. So I've just deleted that box and I'm putting another time. I'm putting WE3 again on the existing box, and now it's okay. So moving towards WM. Oh, that's again a mistake. So let me delete this one. Again WE3. Oh, sorry, WM3, WM4, and WM5. Okay, now CE1, CE2, CE3, CE4, CE5, MJS1, MJS2, and MJS3. WLB1, WLB2, WLB3, and WLB4. Oh, sorry, I think I have inserted WLB3 again. Let me add WLB4 over here. Okay, it's okay now. So let us delete the remaining items first. There are only 3 items in WE, so let me delete all the remaining items. Here is also one extra item, so I have also deleted that one. Similarly, we have to delete all the remaining items which we have put extra on the variables. Now coming to the aesthetics, I'm just adjusting the latent variables so that it may not look awkward. Setting the arrows. Okay, so now I have to arrange the variables in an order. So first let me select the constructs for CFA. In this model, there are 5 independent variables. One, JS is the mediating variable, and work performance, WP, is actually a dependent variable. So what I'll do, I'll first arrange the variables in an order by using the statics. This rotate icon will rotate the items. By using this reserve symmetries icon, we can adjust the size of the items. As you can see, when I'm adjusting the size so that all the constructs can be arranged in a single line, so that aesthetics can be improved. When I select the move objects, uh, the whole construct can be moved from one place to another. Let me just arrange the constructs so that we can run CFA first. As you know that when we run SAM, we need to conduct first CFA, then we need to conduct the structural model. So right now I'm just going to conduct CFA. Let me just rearrange the construct so that one remaining latent variable can also be aligned. All right. So first what we need to do is we need to name the constructs, but you have to make sure that the constructs name must not be present in the variables. As you know that there are already with some mean variables present in the data, so I am just renaming it with the underscore value. That is WE, that is W underscore M, this one is C underscore E, this one is J underscore S, this one is MJS, and this one is WLB. First I am saving the model in the folder of AMOS model, and I am naming it model 1 CFA, because we have to conduct CFA first. Okay, first we need to rename the unobserved variable, or name the unobserved variable, so the all the error terms are labeled right now while selecting the name unobserved variables. Then from plugins option, I am going to select the option of draw covariances. Oh, but I have not selected any constructs, so let me first select the constructs. Okay, all the constructs are selected, so we are going to draw covariances right now. Okay, Let me rotate the constructs to the right side so that these covariances can be viewed properly. I'm deselecting these constructs. Now I'm moving one constructs. I'm moving each construct one by one. Okay, so now we are going to conduct the analysis. First, we need to check the analysis properties, and in output, we have to select indirect effect, factor score weights, standardized estimates, covariances of estimates. In bootstrapping, I'm selecting the perform bootstrap, although bootstrapping is usually done in SEM, and right now I'm doing CFA, but let me select bootstrapping right now. So in analyze, I'm clicking on the calculate estimates. Let's see the result. Honestly speaking, I don't know like what will be the result because I'm also running this model for the first time. So let's see what's the output. Okay, in view there is an option of text output, view text output. So when you click on this option, you will get a window in which there are all the results. Okay, so you can see that the message over here is that the result that follow are therefore incorrect. It means there is some issue in the data that exists. Perhaps there are one or more repeated variable, I guess. We need to rectify it. And in model fit analysis, we have to see the CMIN, that is chi-square minimum. Chi-square minimum is like GF. This GF is the degree of freedom. The value must be less than 5. RMR must be less than 0.05. GFI, AGFI, and NFI, IFI, ELI, CFI, all these values must be greater than 0.9. PNFI, PCFI must be greater than 0.7. RMSEA must be less than 0.08. So it seems okay right now. But several indices are not in the range, so we have to see the estimates first. When we see the standardized regression weights, we can see that all the items must follow the range of 0.7 or greater. So here WP1 is showing the value less than 0.5. 0.5 is the cutoff value, and we need to make the standard latent constructs on the basis of the values based on 0.7 or above. So right now I'm just pointing out which values are less than 0.5. So here you can see that WP7 is the whole construct that needs to be dropped, which means that the confirmatory factor analysis is not satisfying this construct, and WP is actually the dependent variable that was work performance. So you need to okay, no, basically there are three items which may be dropped, so WP will remain sustained. Okay, WP1 and WP89. Let me first delete WP1, WP8, WP9. I'm saving another model for this purpose. WP1, WP8, WP9. Okay, I have to draw a regression weight 1 because the first item was having the 1 value as a regression weight. So I am reanalyzing the model. Now you can see that that error was actually gone. Error is actually gone. And when we see the model fit indices, there is a slight improvement, but we need to work further. So for that, we need to see which are the items that are still less than 0.5, or because 0.5 is the cutoff value, but ideally all the values must ensure the value of 0.7. So let us see if there is another value which is less than 0.5, we must delete it. Yes, there is one, CE1. Because it's almost 0.5, so I'm not deleting CE2. Let me first delete CE1. CE1, and there is no other value which is less than 0.5. So first let me delete CE1. CE1. You have to put regression weight because I have removed that item in which there was the regression weight of 1. Okay, now again when we see the model fit indices, the values are slightly improved, but these are not again the satisfying values, so we need to further delete the items that are less than 0.7 or maybe 0.5. Now we'll start deleting the items having 0.6 values. So here is the value of WLB4, WLB4 and JS5, WLB4, JS5 and CE2 as well. CE2, WLB4, JS5, CE2, WLB4, JS5. So I am reanalyzing the model. Let us see what's the result now. Okay, so IFI, CFI values are greater than 0.9. GFI is still a bit low, so we can further check that there are some items which are also less than 0.7, so we can delete those items as well. When we see the standardized regression weights, almost all the items are now greater than 0.5. So by deleting the values in 0.6, we may get the actual range. So that is WP6, WP6 and WP7, JS4. WP6, 7 and JS4. WP6, 7 and JS4. So let us recalculate the values. Hence, confirmatory factor analysis is done as CFI, TLI, IFI, all three values are greater than 0.9. NFI is also acceptable at the range of 0.8 in some cases. However, here chi-square value is also low, and chi-square divided by degree of freedom also gives us the actual range. So we can go for the CFA. PCFI, PNFI, all the partially measures are also above the 0.7, so it is also good. By watching the RMSEA, it's less than 0.08, so badness of fit is also under the range. So I think this we can say that this confirmatory factor analysis showing the uh, actual model, so we can stay with this model. We'll now have to run the SAM, and in next video inshallah we'll conduct the SAM analysis, that is structural equation model.